Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Welcome to class today. So today, what I would like to do, or what we're going to do, is we're going to talk about Module 3, which is Systems and Scanners. And basically, we're looking at input and output handling here. And so we're looking at output handling, which is system, and input handling, which is a scanner. We're going to take some time and cover this material just so we can kind of understand all of this in a little bit more depth, right? So sorry about that. Just had to reply to a message there. Just one more moment. Sorry about that. So we're talking about system and we're talking about scanner here today. And so we're going to talk for a little bit about just what these different things are. We're going to code. We'll go back and forth and do a few different things here. And so the first thing that I want us to talk about is the system class, right? And so the system class, when we're thinking about the system class here, basically we can think about it like playing a computer game, right? Like if you're playing a video game on your computer, in this game, you kind of have some tools and different commands that you can work with to interact with the game's world, right? So the game exists in a world and you exist in a world, right? We exist in the real world, the game exists in the game world. Well, similarly, right, the system class in Java is kind of like that, right? Like we exist in our world, the system class in Java exists in the Java world. Or basically the interpreter or whatever environment your program runs in. So when we think about what system is, the first bullet here says that system is a class that provides methods related to the system or environment where your program is run. So basically, you think about that like it basically gives us a way to transmit or talk about things that we're doing in the real world and relate that to, or allows us to have commands, I guess is the better way to put it, in the Java programming world, right? So it's like that toolbox. And so the world or the environment for the program is kind of like the tool for the game. It also provides us with something called system.out, which we've been playing with a little bit, right? We've been playing with system.out a little bit as we've been getting started in working with Java. And we've been doing that by using the println function so far, right? And so if we look at our Java println here, we can see like this is what we've been working with. We can see that our output here is system.out.println. And so if we want to break this down, and we want to use this to sort of match up with our analogy that we had earlier about the video game world, we can think about this like a megaphone, right? Or a walkie-talkie, or something that we're using to kind of communicate with Java to send messages out. Right, so when we send out, we are basically just sending messages out, right? And in this case, we're printing line, right? And there are other things that we can do with this, right? Like, so far, we've just used print line. You could also use print, which is going to print things. Print line prints a whole line. Print just prints that string or that value or whatever, what have you. So if you had multiple system.out.prints in a row, then they would all print side by side with one another, whereas system.out.println prints each on new different lines. And then there's also a printf that we talk about a little bit later on. Printf is for print formatted. And so what's interesting here is that if we look at, say, system.out.println and we print from here, right, we get our message echoed back out to us. But what would happen if we printed system.out or just system.out? Right, what happens if we print system.out? Well, when we print system.out, we see we get a response here. Right, and that response is the print stream, which is really fairly interesting, the Java print stream. So with the Java print stream, right, we basically are, what we're looking with here is, it's called a print stream. We can kind of think about it like a printer, that you might have connected to your computer, right? I think that's a good way to think about it. It's just like a printer that's connected to your computer, and this printer has a location, right? And really what we're looking at here with this java.io.printstream at 49476842, right, is basically it's basically a location in memory where the printing is happening. Because we have to have some sort of information in memory for it to be able to translate and print out. So it's kind of like an address that we can think of there to use. So we can print various representations of different values, which we talked about, data types and things of that nature over the last couple of weeks. And so one specific print stream is system out. There are other print streams as well that we don't really use in our program. But it is interesting to know that that exists somewhere, and it's sort of the catalyst that's kind of carrying this from one place to another. Now, if we were to get a little more in depth with this, we can see that, basically I have a slide for that, right? The output indicates that system.out is a print stream, which is defined in a package called java.io, right? We saw that, let me pull that back here. We saw that here. We have a package called java.io. Here, java.io.printstream. And all we're doing is we're adding functionality to our output stream, right? So the ability to print values, the numbers after the @ sign are the address of system.out, represented as a hexadecimal base 16 number, right? And so that's that @ symbol that is right here. We have this base 16 hexadecimal number. That's the address of system.out or system.out in the in the environment, right? So it's just something that's interesting. And so whenever we use a print line or a printf or a print, just a print statement, it's sending things through this system.out print stream, which takes it from that address in memory and sends it out to the console or sends it out to other places, right, wherever it is sending it out to. And so that's outputs. And for the purposes of this course, we are very simple with outputs, right? We really don't do anything outside of the console, with the exception of what we do with GUIs in the last module. So this is going to be our primary concern for the majority of the course. Right, the other thing we want ourselves to deal with is the scanner class. And so scanner is a class that provides methods for inputting words, numbers, and other data, right? And scanner is something that we have to import. Right, so it is a library that is not included in Java by default. Right, or I should say that it's not included in your regular Java runtime by default. It is in the Java program overall, but it's just not in the run. And so it also uses the system, right? That system class that we discussed earlier, because that system class is the way that we have, the ability to talk to the system, to send messages to the system, to get messages back out of the system. And so we can kind of think about this as the other half of that walkie-talkie or what have you, right? Being able to listen into other people's input. Right? And so the big deal about Java is that you're able to allow the user to define a value, whether it is text or whether it is a numerical value or what have you, that you can use in programs. All right, so this makes things immediately more flexible because we're not just, using static values or variable values anymore. Right, we have the ability for our program to take a random value from the user. And now we do have to import it, and the import statement is super important, right? Because that basically tells it what scanner you mean when you say scanner, because technically different classes could have the same name. So you want to make sure that you're pulling the scanner from the right place. This is the java.util scanner, which is the one that's built into Java. Other programming languages, however, though, could have different, or not other programming languages, other modules, other libraries for Java. Could also use scanner that wouldn't be this scanner. Right, so let's look at a couple examples here. So the first thing I'm going to want to do is I'm going to want to import scanner. And I'm going to import scanner at the system level, which means I'm going to go up here to the tippy top and import scanner up there at the top. Now there are other places that we could import scanner. And there are also other places that we could instantiate our scanner. In Java. Right, and so we'll kind of look at those as we sort of progress. Right, but I'm going to go up here to the very top, and I'm going to import Java, and this is lowercase java.util.scanner, uppercase S scanner. SCANNER. And so now when my computer goes to run my program, it knows, hey, scanner, I know where that's at. I can go pull functions from there. Now, in this case, as we've said in the past, if we look at something and we identify it with an uppercase letter as the first letter, we know that that thing is probably a class. So scanner here is a class in the java.util library. And this scanner class in the java.util library has a bunch of functions that go with it. So what I need to do is I need to make a new object of this scanner class in memory so that I can use this in my program. And so there are different ways that we can do this. One of the ways that we might want to do this is by just putting it into main, right? Especially while we're starting here, we could just create a class in main that, or create an object in main that would be a scanner object. And this is going to be the easiest way to do it going, as we're getting started here. Once we start to do more methods, right, we're probably going to want to do it the other way that I'm going to show you. But this is the easiest way that we can do it here as we're getting started. And so I'm going to write the word scanner, uppercase S in scanner, right, because that's the data type of this object is the scanner class. We give it some sort of name. Typically the name that we will see for our scanner is something like N or I or maybe even just scanner, all lowercase, right? Doesn't matter what you name it. It's like naming a variable like we talked about last time. The name of it doesn't matter as long as you meet the variable naming rules. I will typically use N, but sometimes I will change it up a little bit, just to prove to you that it doesn't matter what its name is as long as you're consistent. And this is going to be a new scanner that is going to be listening on system.in. So it's going to use that in method in the system class to be listening for input. And that's what it's going to use to be able to get the information. Right. Alternatively, we could instantiate our scanner at the class level, which might be something that we want to do in the future when we start to work with multiple methods. This way we can have one scanner that we can use in multiple methods. So we would do that at the class level, which means to do it right underneath public class main. We'd basically do the same thing here. Scanner in equals new scanner on system.in. But now one of the interesting things is that in a statically scoped function, which is what main is, right? We have our keyword static here. In a static function, it actually can't reach this on its own. So if I tried to call, say, int num equals in.next int, it's not going to be able to reach this scanner class that we've put out here at the class level. Right, we can see I have a little squiggle here because it can't reach that. Right, so if I tried to run that, it's not going to do anything. It's going to throw me an error because I have a non-static variable in a static context. Right, so what I would actually have to do is create an object of the class that I'm in for this instead, right? So I would create in main, I would create a new main object of the main class, which is referring to this class name here. So it would be main, something like obj or o or whatever, right? It could be whatever we want it to be called, equals new main. And so now we can refer to this as o dot in dot next int, which would allow us to reach that scanner that it is at class level, which would make it accessible in all methods in our program. But for right now, especially while we're not using multiple methods yet, it is just easiest to just instantiate it in the main method. And if we do that, we don't need any of this. We can just do something like that, right? And we use in here, in, because that is the name that we've given our scanner object, right? So if I named this scanner object something different, if I named it like apple tree, doesn't matter, right? It's just a variable name. And so in that case, this would be apple tree dot next int, right? Because that's just what I've named my scanner object. Doesn't matter what we call it. But this is going to give us the ability to enter text into our console. Right, so you can see here I pressed the run button, and you can see it hasn't stopped yet, right? Like normally in the past when we run our functions, we would just press the run button, it would do its thing, and it would stop. It's not stopped yet, right? It's still running because it's waiting on me to do an input. So I need to put some kind of input in here, and I use next int here. And next int is for integers. So I need to enter an integer here for it to finish, basically. Right? If I enter anything else besides an integer, I'm going to throw an error for my program, right? So we'll just enter an integer here like 12, and we'll hit enter. And now that stop button at the top changed into a run button because we're done, right? Like it did the thing that it needed to do, and it ran. Right, so the thing that we could do here, and I'll just take this line here and move it up to here. Right, so the thing that we could do here is echo that value back out. Right, like that's one of the first things that we would start to do is just to take a value in and then echo a value back out. Right, so I have this value being stored. So this value here is being stored in this variable num. And so if I were to system.out.println num, that's just going to take whatever number that our user enters in and just echo it back out to us, right? Which is pretty simple. Right, so all I want to do here is run this. We can see it's just running. It hasn't stopped yet. And so I can enter in some value here, and then I get that same value echoed back out to me. Now, one of the things that we notice here, right, is that when I run this, I don't know what I'm supposed to do. I have no idea what I'm supposed to do here because I don't have a message from my program telling me what I'm supposed to do. So typically what we will do is we will use before what we see here on what is now line 11, we will use a system.out.print. We will use a system.out.print instead of a system.out.print line because it will put this message on the same line as my input. And we just put some kind of string in here, like enter a number. Right, notice that I put a space at the end there of enter a number. That will put a space in my output. Now let's go ahead and stop this. It's still waiting on me to enter a value there. That will put a space on my message between my message to my user and where they're going to enter the value. All right, so now when I run this, I get prompted. Whoops, forgot my semicolon. That happens. Let's go ahead and clear out our console. So we see now when I run it, it says enter a number. So I know that it's waiting on me to enter a number. I enter a number. It echoes the number back out to me. And so we only need to make one of these scanner objects. And I'm going to change the name back from apple tree, right? Because that's that won't make much sense out of context, right? So I'm going to change it back to n. So we only need to make a scanner object one time, and we can use that one scanner object multiple times, right? So if we wanted to say get another number, we could just system.out.print. And in this case, what we might want to do is put an empty system.out.print line, right? So it makes a new line. Or we could put system.out.print. And in there, we put a /n. That is an escaped new line character, which means it's going to break a line. And we would just put in there, enter another number. Right, so that's going to give us the potential to enter another number. And we would do that on int num2 equals n.next n. Right, so the scanner object is still the same, right? It is still n. It's still using the next int function to take the integer that our user enters in and passes it back to, in this case, the variable num2. And so if we wanted to add these two values together, we could just say system.out.println num1 plus, or num plus num2. Right, and so that's going to give me the ability to enter a number, to enter another number, and then my output is going to be the sum value of those two numbers. Right, so I enter a number, let's say I enter 7, I enter another number, let's say I enter 13. I get 20 as my output, right? And so I've not put any static values in my program here. All of the values were put in there by the user as they were using my program. So you can see that that means this is much easier to use in terms of versatility. Which is pretty cool, right? And if we wanted to, we could even take this output here and make it a little more useful. Right, so we could say something like num plus num2 equals num plus num2. Right, so that just gives us the full context of the output there. Right, so if we take that, enter a number, let's enter a number like 45, enter another number like 32, 45 plus 32 equals 77. Right, and so that's pretty cool. So a couple things to notice here is that these next items here are pretty specific to sort of what we're doing with the value. Right, in this case, we would have to know that the value is always going to be an integer value that we get input, right? Because we're getting next in. So if we could get a floating point number or a double, right, we'd have to change everything that we were working with here to be able to accept a double. In which case, these ints would have to be doubles. And next int would have to be next double. But now we have the flexibility to do math with floating point or decimal numbers, right? So if I were to say something like, enter a number, okay, this is going to be 4.78. This is going to be 4.783. And another number is going to be 6.127, right? Since we're using double values instead of integer values, it's going to allow us to do the precise math accordingly. Now, this is going to cause us a little bit of trouble if we use whole numbers here, right? Something like, 12 plus 5, right? So we get 12.0 plus 5.0 equals 17.0. So in such a case, what we might want to do is do some typecasting. That's something that we'll talk about in a future live class, is how we would look at something like this to do a typecast and change that from a whole number to an integer, right? And we would actually do this via some conditionals, which we haven't talked about conditionals yet, so we would need conditionals to be able to do that. But I can basically say something like, if n.has next int, then pass it to this integer variable, else if n.has next double. We can kind of show this as an example really quickly here. I can say something like, if n.has next int, we would store that in an integer variable. So int num equals n.next int. Else if n.has next double, we would want to do double num equals, right? And then instead of taking and then so we could just do a little bit of testing that way, right? And so if we were to run this now, and actually kind of getting a little bit ahead of myself here. So let's just run, instead of this, because we'd want to do a little bit more to this line, let's just comment that line out, and let's just system.out.print line num, because we would have to do a little bit more to this line as well. And I don't have my notes out here, and I'm trying to think about doing this right off the top of my head. Because I think the problem here is that these are inconditionals. Let's just look up the documentation. If you forget, just look up the documentation. So I think what I might want to do here is let me try to remember here. New scanner. And let me look up the. We're getting the documentation here as well. I have it open in another window, so I'm just kind of reading through it really quickly. I think this should work. I'm not sure what I've done wrong. Um, it might be. Might want me to do that. Have a different number there for that. Oh, that's still not a thing. What do I need to do? Let's just run a test real quick, shall we? So we can always run a little test. I'm going to do it in another if and else if block. So that is limited to the if statement. It is scoped to the if statement. That's probably my issue here. It's just that it's scoped to the if statement. which is one of the troubles with Java here. And we'll actually, the better way to do this would be with an else. And just saying that it's an invalid. And just printing out that it's invalid. Right, then putting that in a while loop. Or calling it, making it go somewhere else. So that is getting kind of ahead of ourselves in the scope of this course. So we'll back up here and just get rid of all that anyway. That's what happens when I'm trying to get ahead of myself and I don't have my notes in front of me. I forget things and then it just kind of looks bad. So this gets us back to where we want to be anyway. So this is what it looks like if we use this with numbers, right? Whether that's a floating point number or a whole number. Another thing that we might want to do is use this for strings. And so for an integer we use next int. For a double we use next double. For a string we use next line. Right? So if I wanted to have a string here, string hello, or let's say string name, is going to be a new string object, and the string object value in this case is going to be in.next line. And then so we could use this, for example, to echo back out the name as part of a hello world. Right? So in this case, we just system.out.println hello, whatever the name value is, and welcome to the class. Right, so in which case, right, what we're doing here is we're just getting that name input. It's doing its thing, and it's feeding me this output, right? So if I run this, and I tell you what, let's clear this out. Run it. And what's one thing we forgot to do here? We forgot to put a prompt to our user. So let's stop this for a moment. Let's go back and add that prompt to our user. Otherwise, we're not going to know what to do there. So let's just do a system.out.print here and enter in, what is your name? All right, so now we're going to get that. It's going to ask me, what is your name? I'm going to type in, my name is Mr. Ramsey. And then I'm going to get back out, hello, Mr. Ramsey, and welcome to the class, right? Because it's taking that input value, it's saving it to a variable, and then it's spitting it back out as the output text, right? So it's using that input string, or that input stream, that print stream, or system.in to get the input, and the print stream to show the output for those variables, right? So that's what we're dealing with here. Now, as we are working with this, we see some of our structures here that kind of formulate, right? Most of our Java structures look like this, right? We've talked about packages. We also talk about packages in terms of modules or libraries. It depends on the programming language that you're using as to what it calls something at that level. Right, so in Java, they're called packages. You'll also hear me call them modules or calling them libraries. It's different words in different programming languages. Right, typically in like Python, you'll call them a library, or typically in Python, you'll call them a module. in JavaScript, you will call them a library. And in Java, you call them a package. They're the same basic thing, right? Like it is an item that basically contains a lot of classes. Those classes contain a lot of methods, right? And a method is just a function. Those methods contain a lot of statements, and we said before that a statement is just a line of code. Those line of codes contain expressions. We've said before that an expression needs to be evaluated. And those expressions contain a lot of tokens, right? So that's how we get from big to small with what we're dealing with. Sometimes you just need to use a number value. This is a literal. Right, so the value is called a literal, and that's just a number. Right, and so we put them in variables like var pi if we were going to use 3.14 as a pi value. You know, any sort of variable that we would want to be a constant. Right, another example of what we would term a literal in some cases would be a constant. A constant is a structure that allows us to put a literal variable, so just a data value, into a item that cannot be changed. Right, and so when we do this, we put the term final before the variable declaration. This makes the variable constant. This means that the variable cannot be reassigned. So we can't actually change the value of that data. We'll do an example of that here in just a moment. So while you don't have to, right, it's not going to change anything. Typical naming convention dictates that if we have a constant, we should write the name of it in all caps to differentiate the constant from a regular variable. We could also use printf. We print things formatted in print line. Print line formats decimal numbers to 16 places, if those 16 places exist. Or you could use printf, which stands for print format, to do a formatted output. And I encourage you to look at the Java documentation for printf because there's a lot of little different. In fact, let's just pull up the Java documentation for printf really quickly. For printf, which is our formatter. Because there's a lot of different types of formats that could be used. And basically you're writing something that's kind of like regular expressions, although not quite regular expressions. To do formatting. And this is a good guide that I've used before, and I might go ahead and include this in the class. I don't think I have it in there by default, but this is from Colorado State University. And this just helps to give us our quick reference for the formatted string in a Java formatted document. So we can see here, we start out for the percent symbol, then we use any flags that we need to use, and we see the flags here, right? A dash is left justify. So if we want to have it left aligned instead of right aligned, we could put a dash there. A plus outputs a positive or negative sign for a numerical value. 0 forces numerical values to be 0 padded, which means, you know, if you want to have, say, leading or trailing zeros on a number, that's something that can be used for. Commas are separators. and then a space will display a minus sign if the number is negative. Right, so those are our flags. The next thing we have is a width, and width specifies the field width for the output. So that's basically the number of characters to be written. So we're going to include any space for expected commas and a decimal point in the determination of the width of the value. And so we see down here, right, if we see something like this right here, percent minus 10.2 F, right? So we know that minus is left justified. Then we have a width of 10, right? So that's going to give us 10 spaces. 0.2, which means 2 after the decimal. And then F being our precision value here, which means floating point number. That could also be a D for the decimal precision, which would handle less, right? C for character, S for string, H for hash, N for new line. Which is pretty interesting, right? You could also use this same sort of stuff in the format method to format a regular string. Right, so we'll do this as part of a coding challenge. And we'll try to do this coding challenge really quickly. So I encourage you all to pause here and read this if you haven't, So you can take a little bit to do this, right? Just pause here. Sarah takes 4 classes each semester. She wants to take a program where she can enter the grade point from each course and get her grade point average for the semester. Create a program where Sarah can enter 4 decimal numbers and receive the average. So that's what we want to be able to do. So pause here. If you're watching the recording, pause here, try to do this program, come back, and we'll do the program. And then I'll do replay the video, start playing the video again, and you can see the program in action. So what I'm going to do for this purpose is I'm going to create a new replit. It's going to be a new Java replit. We're going to call it GPA Calc 2024 SP. We'll make this public so you all can see it later. And I'm going to start out just by cleaning up a few things here. We'll clean up that. We'll get rid of all these comments out of here. So we have something that we can work with. And so I'm also going to go ahead and get rid of this system.out.println line here because we're going to use a formatted print here. So I'm going to want to be able to take the input. So the first thing I'm going to need to do is I'm going to need to import my scanner. So I'm going to import java.util.scanner, uppercase S in scanner because it is a class. Right, and then we're going to get our 4 values. So we're going to say system.out. And actually, we need to create our scanner object. So let's create our scanner object first. We could do it really in any order here. So let's say scanner I equals new scanner on system.in. Right, and so now what we can do is we can say, okay, well, what are we getting here? Well, first of all, we're getting system.out.print. Enter grade point 1. right? And that's going to be a floating point number because with grade points, if you have pluses and minuses, right, you're going to have a partial grade point. Otherwise, you also might get grade points out of them, so it's just always, or decimal numbers out of them, so it's just always better to use double values here. So I'm going to say double GP1 equals I dot next double. Right, and so this double variable, right, we just get them all together. And I can basically just copy and paste this multiple times. And just change these values here, right? Because this becomes GP2, and that becomes GP2. This becomes grade point 3. And this becomes grade point 4. Right, pretty easy. So now we have the ability to get all 4 double values for all 4 of our grade points. So now all we have to do is just do a little bit of math. Right, so we could call this GPA equals, and we know that it's GP1 plus GP2 plus GP3 plus GP4 divided by how many values we have, which is 4. Right, so now we have a value that we could use as our grade point average. And we can print this out in a formatted print line. So we will just put here system.out.printf grade point average is, and then our point is going to be let's see, that is percent symbol, (1.2). So that's the width of 1, 2 after the decimal. F, I believe, is what I want to do here. And then outside of the quotes here, we just put the value that we want to use there, which in this case is going to be GPA. So that will give me 1 number before the decimal, 2 numbers after the decimal, regardless of my value. Right, so now we can go ahead and do the work. Whoops, what have we done here? Cannot find symbol GPA. You know what we did? We forgot to give our GPA variable here a data type, right? So that needs to be a double. So that would be the mistake we made there. Right, so let's clear that out, stop that, rerun that. Actually, let's stop that and rerun that again after we clear it out. Right, so let's say in class 1 here you made an A, you got a 4.0. In class 2 you made a B, you got a 3. In class 3 you made a 4. In class 4, which is an A, in class 4 you made a C, and so you got a 2.0. And so out of that you get a 3.25. Right, because 4 plus 3 plus 4 plus 2 divided by 4 is 3.25, right? It's a B average, thereabout. Right, so that's what we're getting out of it. If you got a, say, B plus, you might get a 3.5 grade point average. An A minus, you might get a 3.75 GPA. Right, if you just get a few values here, like maybe you fail a course and you get a 0 for that. Maybe you get a 1.5 for a course, right? You get 2.19. Right, you're always going to get 2 numbers after that decimal. right? Because if we did the math there, I think, let me just pull out my calculator here, do that really quickly. So if we did 3.5 plus 3.75 plus 0 plus 1.5 divided by 4, you get 2.1875, right? But since we have this formatted to 2 decimal places, then it rounds up to that 2.19, and that's what it gives us instead. And so that's the answer to our coding problem. That gets us where we want to be. And that's good enough to finish our live session today. So that's where we'll stop. If you're watching the recording and you have any questions, please take the time to send me an email or a Teams message, and I will answer my questions for you to the best of my ability. We'll send you both this code file and the other demo file out with the recording. That's all that I have for you for today. Thank you for watching. We'll see you next time.